we would like to prove 10 factorial raised to 11th power, which is a big number, by the way, divides 100 factorial, which is even bigger number. So, is this a number theory problem? Sure, you can try to prove using number theory, for this fact. Now, today, however, we're going to treat it as a different problem. Let's look at this combinatorial problem. I have 100 students. I want to divide them into 10 groups, each containing 10 students. How many different ways can you do that? Now, with this problem, you can take the following approach. So first of all, you let 100 students in a row, right? So arrange 100 students in a row, yeah? Now, totally, you have 100 factorial ways of doing that. That's a big number. Once you have that, let's say you have 100 students in a row, yeah, in that order, you can just group them by 10, right? You call this group 1, and the next 10, group 2, and the final 10, that's group 10, right? So when you do that, notice that for the 10 students within group 1, the order doesn't really matter. So in other words, for this one, you overcounted, right? You need to divide 10 factorial here because if the order doesn't really matter, so what you do is the total number of ways for the arrangement is going to be 100 factorial. You have to divide 10 factorial here because for the group 1, the 10 students, the order doesn't really matter. Similarly, for the second group and for the 10th group, the order doesn't really matter. So you have to divide these 10 times, right? Now, at the end, when you think about it, why do you number the groups 1 through 10? The group number doesn't really matter. In other words, if you swap these two, we consider that's kind of the same division, right? So if order of the group doesn't really matter, so you're going to divide another 10 factorial. So totally you have 11 times. Why? So for the first 10, that counts for the students within each group. And this one is account for the group number. So both the order doesn't really matter, does not matter. So this, of course, is exactly 100 factorial divided by 10 factorial raised to 11th power. So this must be an integer because it counts the number of ways you arrange 100 students into 10 groups. So we have proven using this approach, right? So in general, of course, you have n factorial raised to n plus 1's power is going to divide n squared factorial using the same argument, right? You just need to replace this to n squared objects into n groups, each contain n members, right? Same argument here. And then you're going to reach the conclusion here. All right? So that's a general fact. Hope you enjoy the video. Please subscribe to the channel.